So this was a pretty difficult question if you can't exactly visualize what's happening. So I'm going to do a demonstration of this in a little bit. Sorry, my brother and dad are playing trumpet. I'm sorry about that. But anyways, I'm going to do a demonstration after I'm finished explaining what's on this paper to help you visualize what's happening on this with this question. So pretty much we have, we're asking the total like question all in all, it's asking what percent of the weight is the shopkeeper like adding on. And to the each side. So pretty much we have the two pans and they are 62.7 centimeters apart from end to end. That's the length of the of that thing of the bar, whatever. And the fulcrum is being changed 1.02 centimeters away. So ideally, the fulcrum is in the center of the bar from where both pans are equal distance. And pretty much what I did right here is I did length is equal to 62.7 over 2. This is the ideal length, by the way. And I got 31.35 centimeters. And all I'm doing is taking that 62.7 and divide by 2 because this is the total length of the lever arm. That's the word I was looking for, lever arm. Then the next step is pretty much saying it says that the shopkeeper wanted to cheat on the weight, but it's actually mass. So weight versus mass. I realized that this is also another challenging part of the question is the fact that this question is so terribly worded. Weight is the mass times the gravity, where mass is just the mass. And pretty much it says up here that it's being changed 1.02 centimeters away, that fulcrum. So I moved it over to this, if the dotted is the centered and the fully opaque triangle would be the change, that little distance right there represents 1.02 centimeters. So then this means that this is going to be the shorter side of the arm. From here on is the shorter side. So to find the shorter side, I have 31.35, which is that'll divide by 2. And then I'm subtracting it by 1.02. And that gives us the length right there, which is the distance from the fulcrum. And then on the longer side, we have 31.35. That comes from right there. And we're adding on 1.02 centimeters. And that's to give us the length from the fulcrum of like the new distance. And then the next is, so pretty much torque is equalizing the principle about the fulcrum, which is like how balance works. And I'll explain that more in the diagram or in the little representation that I'll do. But pretty much the shopkeeper's design was to secretly sell a smaller quantity, which would look larger using like the scale. So if he places any mass on like with an actual mass of M on the pan hanging on the longer side, then to get the balance of the torque about the fulcrum, he has to place a block of mass M prime on the shorter side. I did the calculations out here. So mass times 32.37, which comes from right there, which is the longer side, and then equals to the M prime times by the shorter side, the distance of the fulcrum. And I had those equal to each other, and then I solved for M prime being 32.37, all divided by 30.33, and I got M prime is equal to 1.0726 M, which M prime has to be bigger than M. And I will explain this. I know this probably makes no sense, but I'll explain it more in a second using a diagram, and I know it'll make more sense. And then to find that in percent, I got 6.72601384768%. All right, so if we imagine this, and we have this pen, so I have to do this one-handed. So this pen right here is going to represent our lever arm, and this pencil sharpener right here is going to represent our fulcrum. And let's say that we have two masses. You have the masses right here, and then you have the mass on this side. And they are of equal masses. Therefore, the lever is not going to move left or right because the fulcrum is in the center completely. However, let's say that the shopkeeper moves it 1.02 centimeters to the left or to the right side, then that means that the left side is going to go down way quicker because the balances are no longer equal. But here's the thing though, the shopkeeper wants to be like, oh, now you need more mass because these are supposed to be of equal masses, right? And we want this side to look equal. We want whatever is here to look like it's the same as this. Therefore, we're gonna have to add more mass. Let's say we add on this side, and then therefore it becomes equal again. We have these two weights right here, and then we have that one right there. So pretty much the question is asking in terms of percent, how much is like he kind of ripping off the customers. And pretty much the answer was 6.72%. And pretty much what that means in this diagram is that this tiny eraser right here is equal to 6.72% of this total eraser. So that's how much is being added on in order for it to look like it's balanced, if that makes any sense. Hopefully that helped.